it has. So pretty interesting. Okay, a lot of tools to know, a lot of things to know, and you know, so we completed a few points. I'll quickly go through it because yeah. Yeah. So let me know once you see the screen. The
Yes,
screen
sir.
visible. Do you see the presentation, right?
Yes, sir.
Okay, thanks for confirming. So the unit basically consists of like a lot of design process and development mechanism, methodologies, like some flowchart, some like testing methods, some standard design processes and stuff like that. So lot of concepts we will go through in this units, like lot of small things basically, not very huge stuff, okay, but small things will do. Okay, so uh, actually we started this on Friday itself. So basically, basics of design. Okay, design is basically the process that you follow to develop a product, and basically there are three important points to it, which are like time to market, design, cost, and quality. Time to market is basically product from ideation to actual market, so that the time taken to for product to develop and market. So that's a time that we are talking about here. Then design cost and quality, so design cost, you try to keep it down all the time so that the product cost doesn't crosses some limits. Okay, because more the price of product, less it is going to be sold, is the possibility. Okay, and quality. Okay, that is again an important thing. Okay, uh, but joining. So yeah, then few design methodologies like flows and stuff like that. So basically, uh, this is a bit of theory of the waterfall model for software development. And though it is an old concept and not relevant, okay, it's not considered relevant in today's world, the way the software industry works. Okay, but still we need to learn it so that we can establish a connection between how it was and how it is today, and how the things are being done in today's world. So it was like this. Okay, and lot of things here are like it is mostly top down approach, as you see it is. Okay, but definitely a lot of things you know needs to be, things do not work this way all the times, right? So it has to be like pretty dynamic in nature if the system has to be built the way we build it in today's world. But it wasn't the case earlier. So if a system is to be built using this model, then you have to know each and everything. Okay, each and everything, okay, in advance only, like in the from the if this requirement stage, then everything has to be properly done here. Okay, and like I mean this by this. Okay, you have to know everything in from the very advanced times, because there is no chance you can go back with such models, because every step finishes then and there, and then only we move on further. Okay, nowadays that doesn't happen. We work on a part, okay, we deploy that, okay, and then again we come back again, we look at if we look at the agile methodology. So this isn't how it works today. So, but this is the basic. Then came the spiral thing. You might have already gone through this, the spiral model. Okay, so basically the waterfall model states that system is built once. Okay, but here the system is built multiple times. Sort of things that happens in today's world. So spiral model looks something like this. Okay, in every phase of its development, requirement test and design keep happening. Okay, and as and how you move ahead with time, the spiral gets on bigger and bigger in size. It indicates the complexity of the work, okay, being increased. So this is how it works. And yeah, so basically on every phase we are refining our system. Okay, and this is called successive refinement, and this is how it looks like basically. So suppose it's initial system, suppose it's refined system. So everything, like everything happens in every stage basically. Okay, means we build the system multiple number of times. Okay, then how actual embedded system development uh, looks like. This is how it looks. Okay, so basically requirement and requirement and specification phase, and after that architecture in which we are just designing your system maybe on paper. Okay, and that's how it works in the first. And then comes the hardware and software development as independent part of the system, hardware design and software design. So after these things are done, and these two tasks can run independently. Okay, and then the integration happen, and then of course some tests are run. So hardware team and software team could definitely be different. Okay, not relating to each other, but still once they develop their own systems, they have to test it their own way, and then only the integration happens. Okay, and then there are some common tests that are run on embedded devices. So this is how it works. So this is the flow that we just saw here. Okay, just more detailed view. Okay, the hardware thing and the software thing. Okay, define in more details. Okay, so it's going here. I mean, this is the basic diagram and the expanded version of each phase. Okay, so hardware system and software system or design patterns. So state machine patterns. So you have already learned state machine. So state machine is nothing but the representation of different finite states that embedded system can have, and this is one of the best way to manage the complex system and to design it further and to you design it further to the completion. So it's not the actual representation, but it could be represented this way. I mean, state machines are sort of they look like this. Okay, so just for the you guys to relate. Okay, and just for relevant standpoint. Okay, states are represented like this with input and outputs. Okay, and how the states are changing, and this is basically then converted into a code. Okay, depending on the way our code is processing. Okay, this is nothing but the state machine. And these state transitions, okay, this is only for the complex system. Okay, mostly followed in like VLSI designs and stuff like that, but this is one of the design part. Because VLSI is again and embedded system. So yeah, so this is how state machine works. So then we observed few I mean we've seen few more design patterns, including this observer pattern. So the issue that it addresses is, suppose there are multiple resources in our system, resources or multiple tasks in your code, and certain event is occurring from a sensor, then everybody has to be aware of it. Okay. And this tight coupling basically creates an issue. An observer pattern in the code, how it solves the issue is that it uses a subscriber model. Okay, so whatever are the tasks that whatever tasks want to be aware of, and any event that is occurring from externally, then it raises a subscription. Okay, and once the subscription is raised, then only the connection is made for conveying the stuff to the particular task. So this is basically observer pattern. Rest of them will observe. Okay, and this one will receive the information, and if they subscribe, they will also start receiving the information. So all the extra connections are avoided here. Okay, so this one thing. Then singleton pattern again here. Here we are just doing one thing. Okay, we are uh, addressing issue of, suppose there is a resource and that needs to, it should be accessed by only, okay, one instance. Okay, only by one instance across the system means, so you're creating a class, then creating only one instance of it and calling it by that instance globally. Okay, there should be a single point of access globally in the code for that particular resource. Okay, it states that. Then command pattern, it basically converts, okay, it basically converts a command or task into an object. Okay, into an object. And what happens after, because of this, is that suppose features like undo or redo, okay, are possible, because then the whatever actions that we are executing in our system can be stored as a history, and in the form of command. Okay, rather than an function or a task, it might be saved as a command, and then uh, from history it will be picked one by one, and then if if we have implemented a thorough history stuff, then definitely undo can happen, redo can happen like we do normally. Okay, so this is also recommended, and this enables, if this is best practice for enabling the logging in your system. And there is something called strategy pattern. So this is basically the dynamic selection of algorithm or behaviors at runtime, depending on the operation context. Okay, like low power, or a strategy based on battery level. Like it can dynamically switch between the modes of operation. Okay, suppose there is a low power thing, it will switch directly depending on the battery health. So this is strategy pattern. So this is the strategy that I am telling you. You might have some other strategy, like you might say that increase, I mean, run the system on full power, maybe because you want it to run fast. Okay, you'll run the system on full power when the users are more. Okay, users are more, just an example, guys. Okay, and when the load decreases, enter low power mode, or when there is no load, then enter idle mode. So some things like that could be implemented using strategic pattern, and the implementation is done using, again, strategy object delegation. So then we started with best practices, and it also is in categories like this. Okay, like resource constraint awareness, then real-time consideration, safety and fault tolerance, then testing and debugging, version control and documentation, security considerations. So basically, these are the categories that we are gonna see all the best, practices. And okay, so in resource constraint, what are resources in embedded system? It's basically, uh, hardware resources, right? The memory and storage. Okay, these are resources and the processor. So managing those effectively, basically. Okay, managing these things effectively. Basically, these resources effectively. How do we manage memory effectively? We manage. I mean, the standard practice recommend do not. Okay, don't do much of dynamic allocation, because that is gonna create some losses like fragmentation. Okay, uh, this is for memory management. Okay, then again optimizing our code to fit into the memory, that also matters. Okay, if we are writing unoptimized versions of the code, then that is definitely not recommended. Just a second, let me be back. I need a charger to the light, basically. Just a second. There's some power issues at my place. So yeah, so we were at this thing, resource constraint awareness. So here we saw how memory and processor should be why and how we should manage it for our resource constraints in embedded system, because these are the smaller systems comparatively, and thus relatively low on basically resources. Then power consumption. So as we talked in earlier case also, so we saw how the capability to have control on power management. Okay, and having the inbuilt power mode have come into the market, and we can use such advanced processors and select those if our system requires it. Okay, again I'm saying if your system requires it. Okay, because if your system just to read some sensor data and convey it further, then that basically doesn't mean that you should have some processor with advanced power saving modes, because you would in turns you're investing on a processor, you're spending some money on it. Okay, you do not want to spend money on something somewhere you don't need it. Okay, it's basically going to increase the cost of your product and nobody will buy it in the end. So basically selection criteria definitely matters here. Okay, so what it states is that implement low power mode in hardware when the system is idle. Okay, deep sleep modes for MCUs. MCU is basically micro controllers. Okay, use hardware peripherals efficiently, turning off unused modules like clock, ADCs, etc. And then real-time considerations like prioritize the time critical task and task scheduling. So we saw this in RTOS. Okay, prioritizing the time critical task. If our system is already time critical, then we easily go for RTOS to do the management effectively. It says use driven design for high priority tasks. So uh, one more thing, uh, avoid avoid polling mechanism wherever you can. Polling is where we are checking status of something. Okay, suppose I was checking status of TF0 or TF1 in the timer programs. Okay, how we were doing that poll is we're continuously checking if this flag is set. Okay, we were waiting in the code. Okay, until this is not set. So that is called polling. And if I mean the standard practice, of course, definitely do not recommend polling. At our level it's fine, but at enterprise level it's not fine. So you should implement interrupt based mechanism, okay, in order to address such issues. So then comes task scheduling, again a part of RTOS. And these are, since these are real time considerations, you are getting solution based on the RTOS. Then modular and layered architecture. So this one important thing. Modular architecture means having the all the modules in your system separated, okay, physically as well as logically. Okay, so if this is a system board, then having maybe controller module, then LCD module, then keypad having then kept separately, maybe communication module helps to manage it easily. Okay, then this is but nothing but separation. Then hardware abstraction layer, agile, it's nothing but to example to give, in yesterday I gave was suppose you want to have a single remote control for many things. Okay, single remote control for many things. Just an example, suppose you're controlling your TV, your AC, and let's say some other device like a speaker using, or a fan, okay, using a remote control, which is a single remote. Okay, then if this is possible, it's because of hardware abstraction layer. Then, well, remote doesn't know how these devices work, it's just giving commands. Okay, there is, suppose there are three devices. Okay, and on top of that sits the hardware abstraction layer, which basically is a logic for such tasks. Okay, common logic for executing such tasks. So this is possible because of that. And then yesterday we saw interesting examples as well. So then decouple the components, we already saw that why and how. So the safety and fault tolerance mechanism. So here basically not mechanism, standard practices. Okay, so it says have a watchdog timer in place, then error handling and logging and redundancy in place. So uh, just a second. Yeah, we completed till here yesterday. So watchdog timer. Watchdog timer is basically somebody who watches your system, okay, continuously, and makes sure it's not hung or it's not stuck at a particular point in time. So if that's happening, then it could take appropriate actions. Okay, it is basically a recovery mechanism from hung states. Okay, so safety and fault tolerance में ये recommended है watchdog timers we should have, okay, in place. Then error handling and logging. So proper error handling is important. Okay, I did not explain why now, because you've done it more than probably I might have done. So error handling and logging is such a essential part of system. I can't tell you, from compliance and to safety, and everything is made sure by logging. Because if something goes wrong in system, if something anything goes wrong in your system, and you've enabled logging for that, then you know what went wrong, when it went wrong, and how do you correct it in future. Okay, so that it runs seamlessly, right? So that's why logging is important. And even if everything is going smooth, error handling and logging, what it means is that it could, if you have enabled login, in future you could also have alerting enabled in your system. Okay, if something is not going well, then your system can alert you in advance based on the logs and metrics. Okay, if there are logs, there has to be metrics. So based on the metrics, the alerts get generated, and we can address these alerts so that future losses could be avoided. Okay, then implementing redundancy, considering safety. Suppose in automotive industry. Okay, suppose in healthcare industry. So what happens is, everything is not everything, only the critical components are put in double of the original count. So main sensors are put in, like if we need only one, two will be there. If we need four, then eight will be there. So okay, this for maintaining the redundancy, just in case this fails, this takes over. Okay, because watchdog can do this thing as well. It is watching basically what is happening in the entire system. Okay, if certain errors are there, and in the form of alert, we get alerted that, hey, this sensor is not doing good, what we can basically do is we can disable this, and we can completely switch to other sensor which is good in health. Okay, that's why having redundancy in place is anytime better option. Okay, basically you are delivering a double of systems that consumer ordered in single enclosure. Okay, this is redundancy. And testing and debugging, again a best practice. Unit testing is a type of testing. Okay, just a type of testing. In today's lecture, by end you will understand other types of testing as well. Okay, but unit testing is just a part of testing. Okay, so you might have heard about unit test cases already, as you are into software, so they don't explain. A simulation and emulation. Simulation की importance तो पता ही है तुम लोगों को. We simulate the actual behavior on system, and then do the changes accordingly, and then the system is actually made. Okay, and the system debugging, it's basically nothing but using debugging tools like JTAG and serial wire debugging and stuff like that to step through code on the hardware. Okay, so it ensures that debugging interface is secure and does not interfere with system performance. Then version control and documentation is another best practice they've recommended. So version control, Git, you must have worked on this earlier. Okay, uh, this is definitely version controlling comes in the during the development phase, as well as in the maintenance phase. Okay, maintenance phase. And why maintenance phase? Once the system is system has gone live. Okay, I mean, once the users have started to use it, you still have a lot of work to do. You got to patch the vulnerabilities. Okay, you've got to upgrade the system, you've got to upgrade the firmware, right? Then who will work, how will it be worked? Okay, there is a central repository of a main system, then a lot of developers are working on their own branches, and then they're committing their changes to master, and then that is merged. So this is basically the version control, and Git is the best example. You know it better. And documentation means maintaining a proper documentation is very important here, because suppose you are a team of four people, fifth person comes in. Okay, plus one. Okay, fifth person comes in, he can basically, he has the documentation. If some resource got replaced in team, there is documentation for the work he has done. Okay, so that people know nothing is missing. Okay, and we don't have dependency on people when we have documentation in place. Okay, so updating your documentation for everything that we do in system is the best practice that we should be following. Then some security considerations in the under the best practices are secure boot and firmware updates. Firmware update we just talked about. Secure boot is what it basically makes sure is that secure boot during booting process it makes sure secure firmware only secure firmware will pass the test and it will boot the system into that. Okay, or else it will give you error. Okay, then encryption and authentication. So it says that you have to use some cryptographic algorithms in order to secure your communication channels. Okay, and secure authentication, definitely its importance. Then we got started with design tools yesterday. Okay, we saw a lot of design tools and some of them we are already using. Okay, so these are electronic design automation. Suppose you might have heard about PCBs, right? When printed circuit boards in electronics is it's nothing but on top you find the components placed like this, but on the behind of the system we'll find its parts like this. Okay, so if you turn that PCB upside down, you will definitely notice the things in the from the behind. Like this is a if this is a register, then from behind you will notice it's two connection only. Okay, if you turn the PCB upside down like this, you'll find this connection. So how is this design? How do these parts are done on this board? How are the measurements taken, and how is this done? Basically, these are the tools that make it possible for us. Okay, we basically design a normal circuit, right? Like we do in we have done in basically you know we have used Protis for simulation. Okay, it's just a sample thing I'm drawing for you guys. Okay, actual circuit never looks like this. Okay, so this is a circuit we have drawn. Okay, in such tools, and we have set it to generate a PCB layout. We have set it to generate a PCB layout. Then what happens exactly is it will take the component key dimensions and it will basically leave that footprint. Okay, behind means if the register, it will just have this portion left blank and the lines. Okay, the layout for this circuit would be something like this. So these are readily available tool in market which are doing such things for us. Okay, and even Proteus that we use. Proteus is the tool that we use for simulation. That tool also does this task. This tool also generates the PCB layouts. Okay, and this PCB layouts can be then converted into a print. Okay, and then that can be printed on a hardware, basically the board, and then the hardware soldering happens in the next stages. So is how it works. So tools for doing this is Altium. So for even though we can use Proteus for this, Proteus is one of the best option, but Altium is the proper software to do it. Okay, I have really not used all rest of the three tools, but Altium I have used throughout. Okay, Altium is the ultimate solution for you to do PCB designing. Okay, so it's a very standard software, though it requires license, and it requires you to pay certain amount in order to play with it. But it definitely is the best solution if you want to have the PCB layouts designed. Okay, and similar tools are CCAD, then OrCAD, Autodesk, Eagle, and stuff. So yeah, then there are simulation tools, then LD Spice circuits, and Proteus. Proteus is the easiest UI. Okay, UI is really friendly and Proteus, and that's why I recommend using this, and we use this already. And similar stuff is multisim, but multisim is mostly for when we have subjects like EDC, okay, electronic device and circuits and those core subjects. Then that is where this is more relevant than here in controller thing. Okay, so what happens is that there are some tools which only offer simulation, okay, but there are some the other tools which offer simulation along with PCB design, okay. So that we have to consider before selecting the tool of our interest, okay. Then the FPGA design. Now this goes into VLSI stuff, okay, and VLSI is also an embedded system, okay, and that's why you are able to see it here, okay. And VLSI, we have VHDL का coding, okay. VHDL is Verilog, okay. Verilog hardware descriptional language, okay. VHDL, okay. So this VHDL coding happens, and for that we have Xylin, okay. Xylin to code. In Xylin is fantastic, tool for VLSI designs. I've used it. I would really use Intel Quartus, but I have used Xylin personally, and I love this too. Okay, so recommended. Oh God, did I end up? Wait, something is wrong here. Hey, you guys are seeing my screen, right?
Yes, sir.
Okay. Okay, no issue. So then microcontrollers and processor development tools. Keel. Okay, Keel. We have worked on Keel. You know how Keel looks like and how it works. Okay, you like you might have noticed few questions are from unit number 4, which is this. Okay, in the question bank. So because the this unit is there for your tier 2 already, so the parts that we are going to cover till today will be there in your exam. Almost we will get done with this unit. So as it's only concepts and concepts and concepts, so it's not rocket science. So yeah, Keel you have already used, okay. It's the best idea I feel for embedded development and simulation as well to some certain extent. So simulation as in it gives you a detailed port views and serial communication and stuff like that. So Kale is best comparing to all and all the other software. So there is MP Lab, which is again based on Atmel. So MP Lab and Atmel Studio. So Atmel is basically a manufacturer of controller, okay, and it has its own software as well to control or to manage the ID part of it. So this is that, okay. And MP Lab because again the same for developing the microchip. So Atmel क्या करता है, Atmel के खुद के प्रोसेसर्स है, तो उसलिए उन्होंने खुद का टूल भी बनाया है। लेकिन MP Lab का भी सेम चीज है, ठीक है। MP Lab माइक्रोचिप एंड एमपी लैब, ठीक है। तो माइक्रोचिप के जो प्रोडक्ट्स है वो इस पे डेवलप करेंगे, पिक्स एंड ऑल्सो। देन आर्टोस, we already studied आर्टोस, okay। फ्री आर्टोस तो बहुत सुना है। there is GB, then there is CMSIS, so आर्टोस। so this is developed by ARM, okay। ARM, you have definitely heard about ARM processors. So ARM processor is different subject altogether called advanced processors, okay, which is developed by ARM, okay. And this is again one but expensive OS, Okay, I did not explain about talk about this basically, just giving you an example here. Version control kit, definitely. Then communication protocol simulation tools like Wireshark, okay? Wireshark, you know, right? You must have used Wireshark, right? So Wireshark, uh, and these tools are similar to Wireshark basically. So, guys, let's take break of 5 minutes or so and be back in time. We'll continue that. Hey guys, you there?
Yes, sir.
Okay, so
Yes, sir.
Yes, sir.
let's start. So let me know once you see my screen. Is my screen visible?
Yes, sir.
Okay, cool. So now we are gonna look at certain guidelines for DFT. DFT is designed for testability. Okay, designed for testability. So this basically uh, design level changes. Okay, design level changes that are made in order to uh, make the system more testable. Okay, so that we can test the system easily. Okay, so let's see how it works. First thing that is recommended here is component isolation. We've overseen it like multiple number of times. So component isolation in system makes it easy to understand the system and manage it. Basically understand plus manage. Okay, so this if we are selecting the components, it's also making sure the security of the system. Okay, it does a lot more than just making it more testable or understandable or manageable. But from security point of view, isolation is very important, because only if these are multiple components of your system which are isolated from each other, and one gets attacked, and it gets attacked, but since these are isolated and they don't have access to do a lot of things with other resources, others still remain available to the user, and system keeps serving even though one part is not available. Okay, we can take action accordingly. But yeah, this is one of the use of isolation. But for now, we are talking about making it testable. Okay, system more testable. So isolating it makes it easy for us to test the part individually, independently of each other. Okay, and we definitely have more granular control over them then. Okay, so this is the isolation. Then interfaces and test points. Okay, so under DFT only, if we just to make it more testable, so few interfaces, if we take out interfaces and test points. Okay, so I'll explain you what test points are basically. So interfaces is basically suppose you are connecting your microcontroller to LCD display. Okay, LCD, so this is called LCD interfacing to microcontroller. So making these interface easy, okay, and manageable, okay, and not complicated, gives us a lot of test points to test basically. And what are the test points? So suppose LCD के तीन पिन जो होते हैं, RS, RW and enable, you got to see mechanically if there are signals coming. Then at the end of these connections, what you will do is you will take out the test point. Okay, you will keep the mechanical test point here so that we can probe here and see if there is a actual voltage coming over here. There's actual data coming here. There's actual potential at these points. Okay, we can check that against ground. Okay, this is basically test point. Then we have next thing, ICT, which is in circuit design. So in circuit design basically states that use the testable circuits and design basically testable circuits. What do I mean by testable circuits now? So it states that use testable circuits and design and hardware so that you can probe signals directly at key points. I already explained this. Okay, so then there is something called boundary scan. Boundary scan कभी सुना है तुम लोगों ने? JTAG सुना है? JTAG ever heard?
No, sir.
So JTAG is basically industry standard. Okay, uh, there is some IEEE standard. I don't remember the exactly standard, but there it has IEEE standard as well. So it is basically called boundary scan, and it is basically for testing. It is industry standard for testing the devices, and it is basically called boundary scan because we can do the runtime testing, and because of JTAG implementation of JTAG. JTAG is a protocol as well. Okay, you can go ahead and study that. So it allows for testing the connections and functionality of each pin on any IC. Okay, our microcontroller is also an IC. So basically JTAG allows test the functionality and connection of every pin of the IC without requiring physical probes. Okay, so it establishes serial communication or something. Okay, so without actually probing we can get to know certain things because of JTAG. So that's it. Then other few of the more like few more of the built-in self-test mechanism for making the system more testable. Okay, then it says as implement built-in test functionality in hardware such as self-checking circuits. Okay, built-in self-test. Okay, built-in self-test. It is basically some certain hardware. Okay, readily available. Okay, nothing that we got to do. Certain hardware has this capability. Okay, to do to run certain self tests on it. Okay, so that this is the basically it's nothing but self checking circuits. Okay, you can relate it with boot process. Okay, you know right why boot happens, booting process, what all parts of the booting system process are, it, right? General computer boots, right? What happens, a lot of bits are run on it. It even shows earlier in earlier times, I guess earlier pieces showed that bits are happening and what all are those. Okay, so for example, okay, to talk about it, memory bits can ensure that RAM is working correctly, system's RAM is working correctly without the need of external equipment. So these tests run on system, okay, can tell while booting itself that, oh, this is not working, this is not this device, this part of your device is not working properly, so that we can take appropriate action against it. So next comes is test hooks and debug interfaces. Okay, now debug interfaces, okay, for debugging purpose, and test hooks. So these are self-explanatory sort of. Okay. The debug headers are, they include extra test pins headers, or connections for serial or JTAG, or serial wire debug or other debugging protocols. These allows easy access during development and testing. Then there's UART and SPI debugging thing available. It basically is a simple UART interface. Whenever I say UART, it's serial. Okay, serial interface. Okay, serial communication. We have a label on our controller, right? So it's that. So it's basically for it is basically used to print the debug messages or monitor the internal variables which helps identifying the problem in real time. So uh, it says that test hooks and debug interfaces are equally important. Okay, now this is uh, design and design for traceability. Okay, so it says that version control system again. See, version control systems are so important, right, for traceability purpose. Okay, uh, to track the relationship between the requirement, design, code, and test cases. Okay, this helps ensures all components are covered by tests. Okay, this is version control basically. Did not talk much about it. Version control. Then documentation. Then for enhancing the testability, we basically should have redundancy in place as well. Okay, so that we have certain standard to compare the actual actual readings with. Okay, so suppose there are two sensors deployed in a system A and B. Okay, but A is currently doing all the work. Okay, and B is just sitting idle as a backup. Okay, so we are talking about the testability, right? So always we can compare the standard readings with the idle sensor which is just sitting, because we know this is healthiest part of the system. Okay, because it is never used. So that's why redundancy is important in testing as well. Now let's talk about debugging techniques, certain debugging techniques that we have in place. So there is serial debugging. Okay, it happens through UART. Okay, UART is basically universal, asynchronous receiver and transmitters. UART. Okay, use we can use UART interface, to send debug information such as logs and variable states to serial terminals for real-time monitoring. Okay, then there could be custom debug outputs in place. We can implement a custom serial debug protocol where the embedded system output specific event states, or error messages we can send via the UART interface. Okay, this is very useful for tracking specific issues like timing errors or unexpected behavior. So होता क्या है ना कंट्रोलर सिस्टम्स में sometimes ports are left open. Okay, any pins or ports are left open for debugging purpose. Okay, in future. So when the system is live on site, okay, the system is live basically, these debugging port helps us to gain some data like I just talked about, like logs. Okay, or maybe internal health events. We could gain access to lot of things. Okay, but but there is always but in embedded system. So if these debugging ports are kept open without securing them, then this can cause blunders. Okay, this is an open invitation to all the malicious actors out there to get inside of the system, because there is already an open port. Okay, so this is what it is. And then there is something called real-time debugging. So रियल टाइम ऑफ कोर्स, जब भी रियल टाइम वर्ड आएगा ना embedded में, you you can close your eyes and write about RTOS. Okay, so RTOS are where debugging use debugging tools that support RTOS aware debugging. So there is a term called RTOS aware debugging. Okay, because it's real time, right? So it's different mostly. For these tools, you basically can show task status, thread switches, and task specific variables in real time. Okay, so tools like there are tools, okay, certain tools like Sega, okay, Sega on it is called. Then there is IR. Embedded Workbench is a popular tool for real-time debugging. Okay, for the systems with RTOS. Then there is Keel, definitely. Okay, so these are the tools that are used for real-time debugging. And why I'm saying Keel is used for real-time debugging is because suppose तुम लोगों ने इस पे कोड किया होगा ना, आर्डिनो पे किया है कभी आर्डिनो प्रोग्रामिंग?
सर कॉलेज में किया था, मतलब बैचलर्स के।
खेल में किया था. ओके, तो the way it connects to a software, with a help of a cable, right? There is a kit and you are connecting it to a laptop. So basically the thing is Arduino वैसे ही काम करेगा. Okay, वो काम करता रहेगा and the real-time debugging is something similar. Okay, so it is working. Okay, and then you interface it with your tool like Kale. अभी Arduino का अलग Arduino Studio होता है, तो we use that for that debugging information. But Keel में भी ये capabilities है. Okay, then hardware breakpoints and watch points we can take out. Or watch points. So सॉफ्टवेयर में ब्रेक पॉइंट्स तो पता ही है तुम लोगों को, राइट? कोड में यू पुट द ब्रेक पॉइंट्स ना. हैव यू यूज्ड दैट एवर?
यस सर।
यू द ब्रेक पॉइंट्स एंड इवन इन कील मैंने दिखाया होगा तुम लोगों ने. ब्रेक पॉइंट का दिखाया नहीं है, लेकिन कील में और एक फंक्शन है कि अपना जो कोड है ना, तो हम लाइन बाय लाइन एग्जीक्यूट कर सकते हैं. ओके, वी प्रेस द बटन. ओके, देयर इज अ रन बटन. इफ वी डू इट मैन्युअली ना, this button, then it runs line by line. Okay, 1 2 3 4. तो उसमें ये ज्यादा अच्छे से समझ. तो तुमने इधर ब्रेक पॉइंट लगाया है ना, तो वो मतलब accordingly execute होएगा, and that you can see on Keel. Okay, if you download it, you can give it a check. That is basically breakpoints in software. So hardware breakpoint is nothing but we take out certain points for our debugging purpose, and those are nothing but the hardware breakpoints. Wherever we want, we can do that. Then watch points are nothing but points that are giving us some information, okay, legit information, and that we can use for debugging purpose. Okay, it can allow us to monitor the specific variable of memory locations, or the debugger halts executions when watched values are changed, making it easier to identify issues like buffer overflow or memory corruption. So that's why watch points are also important. We can gain a lot of information, but we always need to securely do it. Okay, securely, because any hardware thing, any point you are taking out of a hardware, okay, what happens is that it always gives an entry, okay, gives entry to, hackers are, smarter than us, definitely. So they always get into, system using such ports. So we have to be more smart. Then comes very important next point, which is power management in embedded. So uh, power management में, why we should be thinking of this is because many embedded systems are remotely deployed on site, or they are portable, right? And they are mostly battery operated. So power efficient embedded system always lead to, good battery life, okay, and less heating issues. Okay, if our code is also not optimized na, in huge embedded system, okay, heating issues happen, okay, heating issues if there is lot of polling also in code, okay, I'm talking about huge system, okay, huge system. There is a lot of polling happening, then also heating happens. Okay, these are small things that we got to take care in embedded systems. But so there are readily available processors, okay, which has low power modes in it. Okay, low power mode. There are microcontrollers and processors available with low power mode, so we can select such, okay, and switch between the modes as and how we require, okay. Then there are low power states, okay. Many microcontrollers have, multiple power states like active, sleep, deep sleep, etc., etc. So in active mode it operates on, its complete power. Then there is sleep mode. There is deep sleep mode. So such controllers also come, and we can, manipulate these mode based on our progress of our program, okay, and these can be basically modified in your code. Then there are some integrated peripherals, okay, we can choose the processors, that have integrated peripherals. Example, analog to digital converters, then timers, communication interfaces, okay, to reduce the need of additional chips and, associated power consumption. So suppose there is a chip, sorry, there is a this is PCB, okay, and you have selected a microcontroller which is very basic, okay, which doesn't even have internal ADC and timers. So what you needed was, so you added extra ICs, okay. This is let's say this is ADC, analog to digital converter, and this is a timer, okay. But what, who is paying power to them? A battery is paying power to microcontroller, timer, as well as this ADC, okay. So what happened here? The battery is going to drain fast. But if you choose microcontrollers which has timer, ADC, and all the peripheral supports inbuilt, then the, power is saved. Because if you're not using ADC, then definitely no power consumption. Same in this case as well. But what happens when you actually start using it, then some ADCs might consume more power. Okay, there is double power dissipation happening. You are providing 5 volt here continuously, providing 5 volt here continuously. But in this case, only 5 volt to the microcontroller. Then the internal circuits will give the power to this. Okay, this reduces the footprint on our PCB also. So PCB जो PCB की जो costing होती है ना, वो based on paths होती है कि कितने paths बन गए हैं तुम्हारे, कितने track है, ठीक है, तो track space भी reduce करता है, okay, and decreasing the cost. Now there is another concept called DVFS. Okay, DVFS is dynamic voltage and frequency scaling. So dynamic scaling is it's like it's a technique where operating system voltage and clock frequency are dynamically adjusted based on workload or performance requirements. Okay, based on workload and performance requirement. Okay, remember this. Workload or performance requirements. So lowering the frequency or voltage reduces the power consumption definitely, but it must be balanced against the system's performance needs. Okay, so then there is clock gating. Now you know what is clock signal and how it works and why it is needed. So clock gating is nothing but disabling the clock to inactive modules. Example, peripherals like ADC, sometimes memory or processors, okay, to reduce the dynamic power consumption. So clock gating भी हम implement कर सकते हैं to reduce the power consumption. And where exactly we gate the power, where exactly we control the this clock. नॉट नेसेसरी लाइक मेमोरी का तो बहुत रेयरली होता है, मैंने तो बहुत कम एक दो केसेस में ही देखा है क्लॉक गेटिंग करते हुए मेमोरी में, बट पेरिफेरल्स में डेफिनेटली। ओके, पेरिफेरल्स मतलब एडीसी हो गया है जैसे हमने देखा इन अर्लियर एग्जांपल। ओके, लाइक we don't use timers all the time, so timer की clock भी reduce करी जा सकती है। okay, to reduce what? Dynamic power। okay, dynamic power consumption। Then there are peripherals called low power peripherals। okay, उसमें भी category है, ठीक है। So low power gated peripherals जैसे कि power down peripherals when not in use, for instance power of sensors, communication interfaces, or displays when not needed। okay, then use of low power sensors। okay, sensors तो externally connect करते हैं ना, तो we definitely have a choice to go for such sensors। okay, uh, if we choose a low power sensor and actuators to consume minimal current during the operation, then definitely low voltage dissipation will happen, and many modern sensors have low power saving mode as well। okay, then comes efficient power supply design। okay, and how is it achieved? Efficient power supply design। okay, so guys, आपने कभी पावर सप्लाई के बारे में सुना है? पीसीबी पे कैसे कंट्रोल करते हैं, क्या होता है एग्जैक्टली? एवर हर्ड अबाउट इट? यस और नो?
Also,
Yes, sir.
पावर सप्लाई, सो बेसिकली अपना जो वोल्टेज आता है ना मेंस से, एसी मेंस, ओके, तो उससे तो अपना कंट्रोलर चलेगा नहीं, राइट? तो किससे चलेगा? तो पावर सप्लाई डिजाइन में ना काफी steps है basically। So first of all we uh, use transformers। okay, तो वो जो भी अपना वोल्टेज आ रहा है मेंस का, ओके, सो वो वोल्टेज को वो कन्वर्ट करेगा डिपेंडिंग ऑन इट्स रेटिंग। ओके, वो कम करेगा वोल्टेज को। मोस्टली 5 वोल्ट के भी आते हैं ट्रांसफार्मर, 10 12 वोल्ट्स के भी आते हैं। ओके, there are available in different form, 9 volts maybe. Okay, so जो भी हमें चाहिए वो voltage हम इसके output को लेंगे. Okay, then we design a PCB. Okay, that PCB, if I recall correctly. So we basically rectify this signal. Okay, we polish this signal in PCBs. Okay, and I mean on board itself you have this power supply design. We convert the power formats, and we get it to the proper format. This is nothing but the uh, power supply design. We have the voltage regulator circuits in it. Okay, voltage regulator ICs maybe. So suppose these ICs are basically only 3-pin ICs. Okay, so this IC is a voltage regulator IC. Okay, VR IC, and it basically has input, output, and ground, only 3 pins. And suppose this IC rating is 5 volt. Okay, or maybe 10 volt. I have not heard about 10 volt, but possible. So 5 volt constant. So when you provide input to this particular IC, it will constantly give you 5 volts at the output. Okay, this is called voltage regulator. Okay, voltage regulator IC. So sometimes these ICs can also get shorted and they also stop working. So efficient power supply design means that we can rely on our power supply. Okay, with the designing that we have done. So suppose the faulty IC is used already in the power supply, and because of that further things are not working well. Okay, then whom to blame? Okay, we will keep testing. Okay, we'll keep testing in the microcontroller kit, but already power supply itself gone wrong. Okay, so efficient power supply design is very important here. Okay, so low power voltage regulator use low dropout voltages. Okay, or a buck converters that efficiently step down the higher input voltage to the required supply voltage for the system. Okay, this is well also talking about the voltage regulators. Okay, the efficiency of voltage regulators significantly impacts the overall power consumption. Okay, and there are buck converters. Okay, so these are more efficient than linear regulators when stepping down from higher voltage to lower. Okay, there's a power getting also, so implementing the power getting to isolate the isolate and shut down power to certain section of circuit when not needed. That can also be done in the power getting. So power supply design, this is how it works basically. So the AC main से हम ट्रांसफार्मर आता है वो स्टेप डाउन करेगा तुम्हारे वोल्टेज को, then it is further given to you know um, rectifier and filters. Okay, I'm not getting into details because that will go beyond your understanding level. So rectifier are basically half-wave, full-wave. Lot of types of rectifier comes, and these rectifiers basically rectify the voltage. So this is how it works. These are rectifier, and then further filters are connected. A filter could be simple capacitor, or there are a lot of types of filters actually. So uh, this the refined state of signal comes after this, and then you attach a voltage regulator IC here somewhere. Okay, and this is the final stage. Voltage regulator is the final stage. Okay, and so this is very important. So we have software level power management thing in place. Next lecture क्या time को है guys? What is the time of next lecture?
9:30 sir.
9:30 है ना, ठीक है. So software level power management. So इसमें what do we do is efficient power sorry, wait, power supply design is done is low power, operating modes from software, because uh, we can usually have these modes controlled in the software na? So use low power wale operating modes. Okay, like I explained in the last slide, like idle sleep, deep sleep mode वगैरह, ठीक है. तो ये सब मोड जो होते हैं स्लीप मोड में, like many embedded systems support sleep modes when the processes stop most internal operation, expect the essential tasks. So that is sleep mode. Then idle mode is basically the processor ka core idle. Okay, but the peripheral are still active. Okay, and there is sleep, there is like idle mode become already talked about. The sleep mode is basically the processor core is powered down, but the certain peripherals remain active, such as timers and communication modules. Okay, then there is deep sleep or power down mode. So in that mode, we have the entire system, including peripherals, powered down with only essential commands like wake up sources, like interrupts are being active. Okay, so if the interrupt comes, then only turn up the system. Okay, wake up the system. There are wake up triggers available. Okay, use external interrupt. We can use external interrupt any times to have the timers to wake up the system from low power states. Then there is definitely optimized code. There has to be definitely optimized code for power saving, right? So when I started working, just a small experience of mine I want to share. I used to write terrible codes, guys. Terrible codes. I can't tell you. Okay, I call when I look at the codes, it will look fine to me. But when I raise a PR, and when even even smaller codes of mine used to get like 20-25 comments in reply, and the when I refine those when I reply to those comments and I modify the code, my code will entirely look different. My code would used to look entirely different earlier. So why was that happening? Because enterprise and corporate level, you always have to optimize your code to the maximum level. That is the standard. Okay, so optimized code is that important. Okay, so we have to like I state, we have to avoid like few tips for optimization. Avoid polling in the coding as much as possible. Okay, so polling consumes a lot of power since the cpu is constantly active. Instead, we can use the interrupt driven mechanism where cpu is only active when an event occurs. Okay, example, a button press or a sensor reading comes. So this is very important. Then we can use efficient algorithms, right? Use efficient algorithms. Hmm. So the efficient algorithm use, it we can use the optimized algorithms and efficient data structures to minimize the core CPU activity, right, and reducing the power consumed by the processor. Also, we can do sleep during the idle times, right? If if the system has idle periods, example like between the sensor readings, make sure that the processor enters the low power state, and during the this time, these are some things that we can control in software, right? Then we can also optimize the communication protocols, right? So communication protocols like Bluetooth ना, so Bluetooth का भी BLE सुना है कभी? BLE आता है अभी, Bluetooth low energy करके आता है. So that is a different thing that consumes less power. So this is one example. So use such protocols now. So low power communication protocol, like we can choose the low power communication protocols that are like Bluetooth low energy, then Zigbee, or there are some other protocols for wireless communication. So these protocols are specially designed for long range and low power communications. Okay, then we have duty cycling. Okay, in wireless communication we can use duty cycling. What is that? I'll tell you. So duty cycling is like where the devices alternate between the active communication and sleep states, right? So this is particularly important in battery powered devices. So in duty cycling, where they basically alternate between the active communication and sleep state. So that is duty cycling. Okay, then power management in peripheral devices. We talked about controller now. So peripheral devices mein, how can we do that? Okay, so we can turn off the unused peripherals, definitely disable the peripherals such as ADCs or timers or communication interfaces or displays when they are not in use. Okay, so this this is one of the most effective ways to save the power. Just a second. God, this elections call I keep getting. So turn off advanced unused peripherals. We can do that. We can always consume the low power sensor. We already discussed these two things at least. Then energy harvesting, we can do like harvesting ambient energy. Okay, so in applications where changing or charging the batteries is inconvenient, like remote sensors. Okay, where charging is frequent charging is basically not possible. Then what happens is like in such case we are when harvest the ambient energy, like consider the energy harvesting technique like solar cells, then piezoelectric devices, or thermoelectric generators to power the system. We can anytime do that. Then power optimized charging also we can do nowadays. That is also possible if using rechargeable batteries. Okay, एक minute. Okay, so if using we can use like if using your rechargeable batteries, use the efficient charging circuits that minimize the losses and allow for energy harvesting when available. Okay, then we have power consumption harvesting and profiling. So power profiling tools. Okay, we can use the power analyzers and measurement tools like Keysight. There is U2351A power analyzer. Okay, or there is a tool called OT. Okay, Arc by QTech to profile and measure the power consumptions of various components of your system. These tools allow us to track the current consumption in real time, measure the sleep mode power consumption and detect the power spikes that might occur during specific operations or events. So this power profiling are basically readily available tools. Okay, basically you built your circuit over there. Okay, whatever the circuit you have in place. Okay, and these tools will simulate the behavior, and depending on your code how you used, it will give you power, outputs, पावर का रीडिंग इन दी एंड कि कितना पावर कंज्यूम हो रहा है, कितना डिसिपेट हो रहा है, कितना वेस्ट हो रहा है. ओके, there is software profiling possible. Okay, we can use software tools that can measure, optimize the energy consumptions like that. There is Sega, there is Energy Trace, or there are other tools available in market that can help profile us the power consumption and optimize the energy consumption by embedded system. So that is one thing. Then there are some operating systems that are power aware. Okay, we have to use power aware operating systems. So we can't just go with like there is FreeRTOS, GB, and there is MOS, are lightweight and real-time operating systems that offer mechanisms to manage the power consumptions by using various low power modes and scheduling techniques. So RTOS again. Uh, FreeRTOS is definitely best, but definitely not for all the applications. But power में भी FreeRTOS ही recommend होती है हमेशा. So then we enter what embedded testing के type से थोड़े से वो देख लेंगे, ठीक है. किसका लेक्चर है इसके बाद?
Yes, sir.
यश का है ना? Okay.
Yes, sir.
So embedded system के testing के types. One and my favorite is static code analyzer. So ये tool ना तुम देखोगे next sem में. I guess you will have embedded security subject ना, तब भी ये tool हम use करेंगे काफी ज़्यादा. Okay, we are using tool called CPP check. Okay, so this tool ना static code analysis करता है. Static code analysis मतलब क्या कि तुम ना without running the code you are actually getting to know the errors in the code. Maybe it is mostly focused on security. Okay, so it normal compiler जो errors नहीं बताता ना, तो वो static code analyzer बता देता है, ठीक है. It clearly shows the buffer overflow, integer overflow. It clearly points out these things, okay, which are not being shown by the normal compiler. It gives security recommendations based on our code. Okay, so it analyzes the source code without executing execution to identify the potential vulnerability, right? Coding errors and adherence to security coding practices. So it basically such tools are also these are MISRA C and CERT C. These are actually security compliance authorities. So our code must be, when we talk about embedded, our code must be compliant with these two at least. Okay, if we are designing a secure system. So in tools के अंदर ना ये भी analyzer होता है, MISRA C check and CERT C check भी होता है. Okay, this is basically the static code analysis. Okay, means without running the code we are analyzing the code. Okay, then there is something called fuzz testing. कभी सुना है fuzz testing? fuzz सुना है कभी तुमने? fuzz techniques, fuzz testing and all.
No, sir.
So there is a tool, just a second. Okay, AFL, okay, American fuzzy loop, something like that. I have also used this during the last FDP, I guess. Yeah, American fuzzy loop. So fuzz में क्या करते हैं पता है क्या? तो तुम्हारी system को ना feed, we can feed the system with unexpected or invalid inputs to discover the potential crashes and vulnerability. So we bombard the system with basically lot of inputs which may be valid, which may be invalid as well. Okay, so there is live fuzzer, there is AFL. So there are such tools available for that. Fuzzing is basically हम bombard करेंगे with lot of valid plus invalid inputs to the system and we'll see how our system is reacting to it. Then there is unit testing. ये तो पता ही होगा. यूनिट टेस्ट किस लिखा है अभी तुम लोगों ने, किसी तुम में से किसी ने? Anyway, so it basically focuses on testing the individual software modules. Okay, individual software modules. Okay, testing होती है इसमें. So it isolates and tests basically. In modules, it tests in isolation to ensure they function as expected. So there is यूनिट टेस्ट का अलग टूल है. ठीक है, मैंने सीपीपी चेक बताया ना ऊपर पहले, तो इधर ना सीपीपी यू टेस्ट करके एक टूल आता है फॉर यूनिट टेस्टिंग. So then there is catch 2. Okay, catch 2 is also good. Benefits are like isolated, and identifies issues within individual code units. Then there is integration testing. Okay, so it's like it verifies how different software modules interact and function together in a system. Okay, tools like typically custom scripts we have to use for test or testing frameworks we have to use. So it identifies the integration issues and ensures the module work cohesively. So integration testing में हम ना how different parts are integrated together वो test करते हैं. And if there is some problem in that, okay, we check, we basically give that a check. Okay, and there is no tool available as such for this. Okay, we have to use custom scripts. कोई scripting language use करते हो तुम लोग? use किए scripts कोई? bash किया कभी? bash, PowerShell? So such we can use. Okay, for integration testing. Then there is system testing. Okay, so it evaluates the overall functionality and behavior of the systems. Okay, after integration. Okay, मतलब जब हार्डवेयर एंड सॉफ्टवेयर का इंटीग्रेशन हो जाता है ना, हार्डवेयर सॉफ्टवेयर, then comes the system testing. Okay, so uh, it's like evaluates the overall functionality and behavior of the system. Okay, may involve emulator, simulator, or actual hardware we can use here. And then benefits are like validate the system performance by user experience, actual user experience. Then we have HIL, hardware in loop. Okay, hardware in loop testing, it says that it integrates actual hardware components with the simulated software environment to test the real world interaction. मतलब अभी जैसा हमने सॉफ्टवेयर पे सिमुलेशन किया ना, तो what we do is that we simulate on software, and for testing purpose the real world hardware is connected. Okay, to test the real world scenarios. Okay, and we do have tools, we do have some specialized HIL platforms. None of them is free, and we definitely don't have hardware to see this. So yeah, I've not used it right now, but there are specific tools for HIL testing. Okay, the this test interactions between hardware and software under realistic conditions we could know. And definitely it would benefit from the perspective of like safety as well as operation, efficiency and functionality. So there are two things now, functionality and security. So if our system functional requirements are met, that is when we start thinking of security, but that is a wrong approach to go, basically. Then comes the penetration testing. Okay, so pen testing is basically optional. Okay, for small systems now we don't do it. Okay, so it simulates the real world attacks to identify the exploitable vulnerabilities. Okay, so real world attacks simulate करते हैं हम, ठीक है? We are simulating the attacks in pen testing. Okay, to understand and identify the exploitable vulnerabilities, right? It requires, specialized skill and expertise skills. So we require those personnel. Okay, we need to hire a team in order to conduct pen test. So this is expensive. So benefits are like it provides, valuable insights into the system attack resistance mechanism. Okay, अटैक रेजिस्टेंस कितना है सिस्टम का वो हमें पता चलेगा, एंड बेस्ड ऑन दैट वी कैन अगेन improve our system further. Okay, so this is where the testing types khatam ho gaye hai, and also this unit. Okay, fourth unit. Okay, so yeah, anything that you guys want to ask me?